All right, this is a video for Unit 11, Day 6. Hopefully you have a copy of the notes nearby that I handed out in class yesterday. If not, you can download a copy off my website and have that to refer to while the video is going. But first, start with the warm-up. So, this should be a little bit of review from what we were doing yesterday. It says a house purchased 5 years ago for $100,000 was just sold for $135,000. Assuming exponential growth, approximate the annual growth rate to the nearest percent. Okay, so if you want to take a couple minutes to try this, it's using some of those formulas that we did in yesterday's class. This was an Old Regions question a couple years ago. And if you want to try it on your own first, go ahead, pause the video, and when you think you've got it, press play, and we'll see how it goes. Okay, so assuming you've tried it, let's see what we know here. It says assuming exponential growth. So there's no compounded or anything like that. So that means that I should be using the formula A equals P times 1 plus or minus R to the T. Okay, so what do we know? House purchased 5 years ago for $100,000 was just sold for $135,000. So this is our initial amount, and this is our ending amount. And 5 years ago would be our T value. So we can put in 100,000 as our initial. We can put in 135,000 as our ending. And it says approximate the annual growth rate. So right there, that says we want R. So I've got 1, is it plus or minus? Right, it's plus because it's growth. So 1 plus R raised to the 5, because that's after 5 years. Our goal is to solve for R. So what would you do first? Well, you could do y1, y2, calc intersect, because it doesn't say algebraically anywhere. So if you want to go that route, you can definitely do that. But we can solve this algebraically. If I want to solve for R, I got to get rid of that 10,000. So how do I do that? Divide. So divide both sides by 10,000. Cancels out over there. Pull up my calculator here. We've got one. Oops, I'm turning it on. I got 135,000 divided by 100,000, and that's 1.35. So we've got 1.35 equals 1 plus R to the 5th. Now, to get at that R, I've got to get rid of that exponent of 5. How could I do that? Well, we've got a couple options. I could either take the 5th root, or I could raise both to the 1/5 power. So whichever you'd rather do, I think it's a little easier just to raise it to the 1/5 power. But taking the 5th root's just as good. Okay, so let me go back to my calculator. I want 1.35 raised to the 1/5 gives me that big long decimal, 1.0618 ... equals 1 plus R. And then finally to solve for R, subtract 1 from both sides. And we've got 0.0618 equals R. So if I want it to the nearest percent, what would I need to do? Move that decimal place 2 to the right. It would be 6.1%. So that would be about 6%. All right, so it's similar to what we did yesterday, a little bit different because of the variable I was solving for, but that's how you would do it algebraically. And again, if you did y1, y2, calc intersect, and also got the same answer, just as good. Okay, so let's now go on to the new stuff. This is the notes I handed out yesterday. And today we're going to be talking about ways to figure out the percent rate of change. It says there are different ways to express exponential growth or decay rates. To determine the percent rate of change, which essentially is that R value, we can relate any exponential formula to that formula we talked about yesterday. So it's similar to what we did in the warm-up. We found the percent rate of change in the warm-up, but some of the questions today are going to look a little bit less straightforward than that. Okay, so what do we know in this formula? We know that P is always the initial, so that doesn't really affect what the percent rate of change is, but the number out front represents that. But what you really want to zero in on is this 1 plus or minus r piece. And whatever's being raised to that exponent of t is what that 1 plus or minus r is. It's essentially the base. So the base is 1 plus or minus r. So the strategy we're going to use is set what's being raised to the exponent equal to 1 plus or minus r. Then solve for r. Okay, so when I say set what's being raised to the exponent, I'm essentially saying the base. Whatever the base of the equation is, kind of the parent function base, that's what is contained with that 1 plus or minus r. So find the base, set it equal to 1 plus or minus r, and then we can solve for r. That's our percent rate of change. And that's basically what we're doing today. Okay, so let's look at the first example. It says, does y equals 4 to the negative 2x represent growth or decay? What is the percent rate of growth? Okay, so first off, that y equals 4 to the negative 2x. Just what is the base there? The base is sort of 4, but it's being raised to the negative 2x. So we can't say just because the base looks like 4 that it's growth, because let me graph it. So step 1, we're going to graph y equals 4 to the negative 2x. Because that's really the best way to tell if it's growth or decay. So here's my calculator, go to y equals 4 raised to the, since this is an old calculator, I got to put this exponent in parentheses, negative 2x like that. Go to zoom standard, take a look at what it looks like, and is it growth or decay? Obviously decay. Very good. So this is the graph I got. And we can say that it's decay. All right, now why, even though the base is 4, is it decay? Because usually if the base was bigger than 1, we said it was growth. Well, it's not actually 4 being raised to the x, it's 4 to the negative 2 being raised to the x. So it's kind of like saying 4 to the negative 2 raised to the x. And what does a negative exponent mean? Exactly, fractions. So this is really 1 over 4 squared being raised to the x, or 1/16 to the x. So now it's a lot more obvious that it's decay, because 1/16 is less than 1. But again, the best way to do it is just to graph it, because you can see it really quickly from the graph if it's growth or decay. Okay, so now the second part. What is the percent rate of growth? So that's what I was talking about with this strategy. Set what's being raised to the exponent equal to 1 plus or minus r. I should have said what's being raised to the exponent of x, because 4 to the negative 2 is really what's being raised to the x. So I don't set 4 equal to 1 plus or minus r. I've got to set 4 to the negative 2 equal to 1 plus or minus r. So it's this stage where I set what's being raised to the x equal to 1 plus or minus r. Okay, so we know that's 1/16, but if I want to get it as a decimal, I could just do 4 to the negative 2, which is 0.0625, equals 1 plus or minus r. Subtract 1 from both sides. So take that, minus 1, and I get negative 0.9375 equals R. So that plus or minus I kind of ignored. It kind of comes out for free when I've got this minus 1 over here. R comes out to be negative, which is no big surprise because it's decay. So my decay percent rate of growth, in this case decay, is negative 93, sorry, just kidding, negative 93.75%. Okay, and that's the general idea of what we're doing here. Number 2. Find the percent change to the nearest percent if f of x equals 2 times 1 minus 0.3 to the negative x. Okay, so we want the percent rate of change, or percent change. So I need to take what's being raised to the x and set it equal to 1 plus r. What's being raised to the x this time? So what I want to do is rewrite this as 2 times 1 minus 0.3 raised to the negative 1, all raised to the x. So I kind of just took that negative 1 out, just like I just took the negative 2 out up here. We really want to isolate the exponent to be just x. Okay, so now once I've done that, I take this piece and set it equal to 1 plus or minus r. So 1 minus 0.3 raised to the negative 1 equals 1 plus or minus r. Well, this left side is just a number, so go ahead and plug that into your calculator. 1 minus 0.3 raised to the negative first gives me that number. So 1.42857 blah 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 equals 1 plus or minus r. We subtract 1 from both sides. It's going to give me 0.42857 blah 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 equals r. And I want it to the nearest percent. Move that decimal place 2 to the right. It'd be 42.8. So r is about equal to 43%. We got a 43% change. So because of the way this formula was written, you can't really see that too well. That's why we had to get it isolated before I could figure out the answer. Any questions yet? Don't see any hands, so let's go on to the next page. Okay, number 3. The amount of cobalt left after T years can be modeled by this crazy looking formula. The amount of cobalt is decreasing by what rate each year? Round to the nearest percent. Okay, so same thing again. We are going to rewrite this as n of t equals n sub 0. That just means the initial amount, don't care, times 1/2 raised to the, now I want this t isolated. So I need just t on the outside. So if this is going to be t over 5.27, what's got to be right here? Well, it can't just be 5.27, because then it would be 5.27t. So it's 1 over 5.27. Then the 5.27 will be in the denominator like it is over here. And when I multiply it, the t will be in the numerator. Okay, so this is the base that's being raised to the exponent of t. So initial amount, don't care. Take this and set it equal to 1 plus or minus r. And technically, do we know if it's plus or minus in this one? Right, we know that it's minus because it's decay. But it doesn't really matter. We could just write 1 plus or minus r anyways. Next step, figure out what this number actually is. So we've got parentheses 1/2 raised to the, and if you got an old calculator, this needs to be in parentheses also, so that it's all in the exponent. And I get 0.8767 blah 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 equals 1 plus or minus r. Subtract 1 from both sides. Minus 1 gives us negative 0.1232 equals r. So rounding to the nearest percent, it's decreasing by, move the decimal place 2 to the right. So that'd be negative 12.3. So it's decreasing by about 12%. So hopefully you're getting the idea. It's basically the same for all of these. We just have to figure out that first step of isolating the exponent of x or t or whatever the variable is, and then setting it equal to 1 plus or minus r. Still good? Perfect. Okay, here's number 4. Which of the following interest rates is closest to 6.2% compounded annually? All right, so this one's a little bit more obnoxious. We've got 3 options. Or 4, just kidding. 6% compounded annually, compounded weekly, compounded monthly, and compounded daily. My goal is to get to 6.2% compounded annually. So I'm looking at that. That's my goal percentage. So that's what I'm looking to achieve. Now, since all these words compounded are in there, what formula did I say to use yesterday if we were compounding? Hopefully you remember A equals P times 1 plus R over N raised to the NT. And it's pretty much the same as the other formula that we've been using, except what's N? N is the number of compoundings per year. Okay, so if I've got 6% compounded annually, annually means N would be what? N would be 1. So I don't really need to use this formula. I could use my other one, because if N is 1, this is just over 1. This is 1. So in the end, it's going to look like P, which I don't know the initial amount, but don't care, times 1 plus 0.06 over 1, which is just 0.06, raised to the 1 times T, which is just T. So this first one's pretty easy, because this is already isolated. I just have to take this piece, take 1.06, set it equal to 1 plus R. I can just say plus because I know it's increasing. Interest rate's always plus. Subtract the 1. We get 0.06 equals R. So in this case, R is just 6%. So when it's compounded annually, it's easy. If it's compounded annually 6%, that's the annual percent increase. But we're comparing it to 6.2%. So far, we've got 6% as the closest. Next one, compounded weekly. So if I'm compounding weekly, what would N be? You know how many weeks are in a year? You should, but I feel like most students don't. Someone out there said 52. That's correct. There's 52 weeks in a year. So if it's compounded weekly, N is 52. Okay, so now you'd use the formula A equals P times 1 plus, the rate is still 0.06, but now it's over 52, raised to the 52t, using this formula. N is 52. So what's being raised to the t? It's this whole piece, including the 52. So I would take 1 plus 0.06 over 52 raised to the 52 equal to 1 plus R. We're going to have to throw that into our calculator. So 1 plus, it's a little bit more annoying to type on these old calculators, but I need all those parentheses like that. That's 1.0617. 9, blah, 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 equals 1 plus R. Obviously, when we subtract the 1, we're going to just have 0.06179 equaling the R. So this gives me a percent rate about, move the decimal place, 6.179%. Okay, so for part A, we got 6%. This one we have 6.179%. We're looking for which one's closest to 6.2. So at this point, 6.179, closest to 6.2. Okay, let's see if we can beat that. Compounded monthly. What would N be if I'm compounding monthly? 12. So A equals P times 1 plus 0.06 over 12 raised to the 12t. I take the piece that's being raised to that exponent of t, which is that. 1 plus 0.06 over 12 raised to the 12 equal to 1 plus r. Go to your calculators. 1 plus parentheses 0.06 over 12 parentheses raised to the 12 gives me 1.06167 equal to 1 plus r. Subtract that one. 0.06167 equals r. To see the percent, move the decimal place 2 to the right. That'd be a 6.167%, not any closer to 6.2 than 6.179. So 179 is still a little bit closer, but that's what we got from this one. So far, this is our winning one. All right, let's try the last one. 6% compounded daily. What would n be if we're compounding daily? 365, very good. So we get a equals p times 1 plus 0.06 over 365 raised to the 365t. Take that piece. 1 plus 0.06 over 365 raised to the 365 equals 1 plus r. We come over here. 1 plus 0.06 divided by 365. Just kidding. 65. Raised to the 365. Give me that number. 1.06183 equals 1 plus r. Subtract the 1. So 0.06183 equals r. Decimal place 2 to the right gives us a 6.183%. So is that closer to 6.2 than our other 6.179? It sure is. So which one is the closest? My answer is choice D. Wasn't that annoying? But hopefully that gave you an idea of how to set up these types of problems, because you can see it's really the same process over and over and over. Okay, great. Let's go to this last page. Okay, so if we were in class right now, I would have you try these on your own for a couple minutes and see if you're getting the right answer. Find the percent change to the nearest percent, determine if it's growth or decay. So why don't you pause the video and try these on your own, see if you can get the answers, and then play the video and I'll talk you through it and you can see if you got it or not. So go ahead, hit pause right now. No, actually hit pause. Make sure you try this on your own. So pause. Okay, I'm assuming you tried it on your own. If not, what are you waiting for? Hit pause one more time. Try them. But if you've tried them, here we go. All right, so first one, find the percent change to the nearest percent, determine if it represents growth or decay. So I could graph this and see if it's growth or decay right away, but I can also see if R is positive, then it's growth. If R is negative, then it's decay. So let's just do that. So first off, we need to rewrite this as y equals 3 times 0.2 to the negative 1, all raised to the t. So we have to isolate that t as much as possible, that variable. So the thing that's actually being raised to the variable is 0.2 to the negative 1. So then I take that, 0.2 to the negative 1, set that equal to 1 plus or minus r. We go to our calculator. 0.2 raised to the negative 1 is 5. So 5 equals 1 plus or minus r. Subtract the 1. So we get 4 equals r. So is it growth or decay? It's definitely growth because it's positive. And what percent is it? Careful, it's not 4%. Because I got to move that decimal place 2 to the right. So it's actually going to be 400%. That represents 400% growth there. Always make sure that R, you're moving, even if there's no decimal, to get the percent, you've always got to multiply by 100. Move the decimal place 2 to the right. Okay, good. Here's B. Y equals 19 times 0.875 to the 4t. So what's being raised to the t? Not the 19, just 0.875 to the 4th. All of that's being raised to the t. So I take that, 0.875 to the 4th, set that equal to 1 plus or minus r. 0.875 raised to the 4th is 0.5861 equals 1 plus or minus r. Subtract 1. I get negative 0.4138 equals r. So we know that it is growth or decay. Decay. And the rate of decay is, move the decimal place, one of the nearest, I didn't really say, we'll say nearest percent. 41.3, so it's about equal to a 41% decay. Okay, and then finally, the last one. This one looks kind of crazy, huh? We did one like it earlier. So we've got W equals N sub 0. What's being raised to the t? 1/3 to the 1 over 9.81. All of that's being raised to the t. So set 1/3 to the 1 over 9.81 equal to 1 plus or minus r. Be careful how you plug this in. 1/3 should go in parentheses, even on the new calculators, unless you're using alpha y equals. Raised to the parentheses 1 over 9.81. That's 0.89405 equal to 1 plus or minus r. Subtract the 1. You can hopefully already tell this is going to be decay because if I'm subtracting 1, I get a negative. Negative 0.10594 equal to r. So we're going to say decay. And to the nearest percent, the decay rate is, move the decimal place, 10.5. So r is about 11%. All right, and that's it. All right, hopefully that made sense. And you've got the homework that goes along with it. It's a worksheet. It says equivalent rates up at the top. So give that a try. Check your answers on the blue sheet. Even those of you who hate checking your answers on the blue sheet, do it anyways. You know who I'm talking to. And good luck. See you next class.